Hello, good morning. This is an application what I developed as an extension for the Mind Trotter optimization app what I had developed earlier. In this one, I have made it in such a way that I can either optimize the location of a radar, a communication system, a transmitter receiver, or the location with just a sensor on it, or just a line of sight. So there are like four things we can do here, and you can see different tabs for each: radar, com, line of sight, and sensors. In the same way for the grid also there is a tab. So in the first section I will show how to do a single execution. You can change the location of your facilities, objects, radars, and how you do an execution and visualize the result. And the second video I will show you how you run an optimization using the same thing. So I'll just activate this. So this is what comes up once you open. So, and you can click on a new scenario. Okay, so this is the main window which opens, and here there are certain things. There are like 6 tabs here. In the first tab you can add some terrains. There is option to add terrains, so I'll just load some terrains in over here, and also I can add some imagery. 30 70 30 75. So there's this region, and also here I can add uh, add an area target, which I just choose India for the time being. And when you open up the scenario, there are certain default area targets which is added. The first three are important. The first one is the operation region, which is actually your region of operations. That means where you want the coverage to be obtained. Second is the no object zone. That is the region where you don't want any of your assets to be kept. That means if it is a radar or a transmitter, this is the zone where you don't want anything to be kept. And the third is the object regions. That means this is the region where you can keep your objects. So the first one is the coverage region, second is the no asset region, the third is the region where you can keep your asset. So the first thing what you can do is you can define your region. So, and I can zoom over it. So I have implemented a zoom button as well over here. So let's decide that over here you can't keep any of your assets. So I just click. So that is the red zone, and this is my region where I can move my assets. So I just put my, so that means my radars transmitters could be anywhere in this region. So this is the first step, and in the second step you have to choose what kind of asset you have. So here there are different options. You have radars, communication systems, line of sight, and sensors. So every time I choose one of it, for example if I choose a radar, so the properties of the radars comes here. If I choose a communication system, so the properties of the transmitter comes. If it is just a basic line of sight, it just puts a facility, and you can fix some parameters here. And if it is a sensor, you can fix again some parameters. So I'll just show the radar as a beginning, and once you choose the radar you can define how many objects you have, whether it is 3 4 5, it could be 2, it could be 1, and it could be any number as well. But for the time I just limit it to this much. So I just choose 4, and then in this window, this is for future work, I have put a settings tab, and I can add any radar properties here, the same way as the properties user interface in the SDK desktop. I can add all those parameters, but because it's a huge task to add all those things, I just loaded the radar file. So whatever radar file you, or I can put a default radar also, it works. You can load a radar file from here, So this is a pre-existing radar file which I have loaded from my one of the folders, and then I can click on apply. And once I click on apply, what happens is it displays all the characteristics of the radar what you have loaded over here, so you can read through it. Then once you do that, the next thing what you need to do is, if you choose the grid, that means on the grid what should be the object. So you can actually save a particular object with an RCS value, and you can bring it over here. You can put it in a aircraft object, and it reads that aircraft object and it can place it. And if you don't do anything and you just click on apply, it just takes a default object. So that's what I did here. And as you can see, this automatically the setup changes to radar over here and also the radar over here. The next thing what you want to do is, like, you have to define your coverage region. So this is what is set up. I can check altitude and above the main sea level about 5 kilometers. So you can see those white dots appeared because it's too coarse. I'll just make it finer. This may be too much computation time, so I just make it like this, around 3 kilometers between each points. So I'll just show a single run. I'll choose one of the facility and I will move it over here maybe, and I click on accept. And once I do that, I can zoom it over here. You can see that facility is added with that with the radar file what you had loaded over here. And then you can easily do a computation. You can go to the, you don't need to, I will show the optimization in the end, because it takes time to do the run. So I'll just show a single execution. If you go to the execution tab, there is one single run. That means it just does a single run with the location. So I just change the facility region. I click on result display and I click on single run. And this is the result what I obtained. Actually all the terrain information is taken into account. That is why what you can see the coverage. And I can move those all the 4 facilities. I'll put one over here, the next over here, and the 4th over here, and I do a single run again, and the result will, so this is the result. So I can keep on moving and find out how my coverage is. So what happens when I click on this optimization button is it starts automatically placing this radar all over within this yellow bounds, and it will, the more time you run, the better result. I will show that execution in the end. Before doing that, I will show some other things also. So this optimization button is very general, so it could be used for radars, comms, etc., as what I said in the beginning. So I'll just clear this off. I'll just now show what happens if it is a communication system. So instead of radar, I choose a communication objects. Everything is cleared up. So I can choose the number of transmitters. So I just choose 5 this time. And in the same way as I did for, you can see that the complete interface has changed from radar to comm. In the same way as radars, I can add settings and bring in all the user interface parameters what we have in the desktop over here. Instead, I just use a transmitter file and I clicked on apply, and you must have noticed that now there are like 5 facilities automatically created. Earlier it was 4 because I have chosen 4 radars. Now it is 5 of them, and you can see all the parameters of the transmitters appeared over here. Now you can go to the grid. In the grid, unlike in radar you were able to specify an aircraft, and the grid file you can choose a receiver, so it should be a receiver. And when I click on apply, all those receiver parameters appear here. So now I'll just zoom to the operations region. You can see that it's the same region and all the granularity, everything the same. So I'll just click on the points and I'm going to bring in those facility, one of the facility maybe over here, and I zoom to it. So this is in the radar it was actually a rectangular antenna. This is the transmit, I think it's a dipole antenna. So I kept over here and I go to the execution tab. I do a single run and the result will appear. So in the same way as for radars, this is the coverage what it provides. Basically, I think I take the received isotropic power, and in the display what I had shown in the radar was actually the probability of detection. So this is the received isotropic power. I automatically put some color coding, and I will show again the optimization, and I'll just add one more here, and I run it again. So there are now two transmitters. So you can see the total coverage in a minute. So you can see the coverage region. This transmitter is actually all the same transmitters. It's not providing good coverage because you have put it somewhere inside the mountains. So that is the transmitter. I'll just clear this off. Now I'll show what happens when it is a sensor. So that is cleared off. Again, in the same way, you can choose the number of sensors. You can choose the cone angle, the range. I'll just put maybe 5 kilometers, and you click on apply. So it creates all the required sensors, etc. And I'll just come here and I'll just move one of the sensors here for clarity. So it was radars, then transmitters. Now I can zoom to it, and it actually had included a sensor. I can put several of them over here, and in the same way as earlier, you can go to the grid. In the grid, actually I'm taking just a default object, that means it is just line of sight computation. I add the grids and go to execution. I do a single run. So you can see the coverage what is obtained. If I in the grid, I can increase the number of points. So if I put 1, so there are no more points now. I put a single run, and you can do the coverage. It takes a few minutes, and you can see the coverage obtained over here. So the last thing before showing the optimization, there's one more last thing. You can just put a line of sight. I have put line of sight because the computation is much easier. If you use a radar object, every single run is like 1 minute or something, but line of sight is very quick. So you can choose 5 of them, and I put a maximum range of maybe 15 kilometers, and then I click on apply. Basically just come here, and go to the grid. Also it's kind of empty, so this is just a line of sight. There is no sensors, transmitters or radars. I click on apply. There is so much points. Just zoom to it, and you can see now there is like 5 facilities because I choose 5 of them, and I put one of them over here, and I do a single execution. So my objective was to show you how you can set up many things at a time, like all these objects. So the entire code is kind of generalized to take up all these things. I'll just reduce the number of points maybe to 3000, so that it's a bit coarser, and I do a single run so that it's much quicker. Now what I'm going to show is like how do you do an optimization. So now I have almost 5 facilities, and now this is the line of sight computation. When you keep a facility here, this is its line of sight region. First I can do an optimization with just line of sight, and because line of sight computation takes only a few seconds, so I can do the initial optimization just using the line of sight, because everything matters with the line of sight. and maybe once it reaches a particular thing, then you can switch on to more expensive radar or like comm system. So it works for everything whatever you have chosen. So at the here I will just show the line of sight one, how it automatically starts keeping it. So I'll just zoom to it, and what you see here is I have just placed only one facility here. I have chosen 5 facilities. Now as soon as I click on optimizer, you can see those facilities starts moving all over here and trying to find out an optimal solution. And you have to go to the optimization tab, choose your optimization method, which is MOGA, we call it multi-objective genetic algorithm. So there I'm going to give 50 runs. It will take some time. So I go to the execution tab and I start with the optimization. So I'll reduce the size a bit so that the computation is much faster. Do a single run, it gives good, so it takes only few seconds. Come to optimization execution tab and I'm going to click on the optimization. So as soon as I click the optimization, you can start that all those 5 facilities have started coming in, and it kind of places all over the place, and it is basically optimizing the entire system. So it will run for the next 50 runs. The good thing about the optimization algorithm is the more time you have, the more time it runs, the better result you get. So I have given only 50 runs, so it will stop at a particular time. There are several parameters which you can change in it to make it more robust, the result. That we can discuss it later, I think, once it starts running. So this is just a line of sight computation. I think the advantage is because it's much quicker. I recommend to do line of sight in the beginning, and in the same way I was showing using single runs, I can do the same optimization for maybe it's the probability of detection, or if it is a received isotropic power. And the objective what I choose is the area covered. That is the objective which is trying to maximize whatever is the object. But we can add more in the future as well. And also here I have clicked on the result display button. That will take a little bit more time because this was for just for demonstration purpose. If I unclick the result display, I think it will be much quicker. So I'll just pause it for some time. So the computation is over now. This is what happens once it is over. It says like the results is computed, and what you see here is all the computation it has done. And here you can see how the facility 1 has changed its latitude, longitude, facility 2, facility 3 is facility 4, and facility 5. This is because we had chosen 5 facilities. If I had chosen 7, there will be 7 location it was trying to optimize. Then there is something which is the area covered. That means this is the area coverage what we have been obtaining, and you can see it started with 12. That means only 12% of the area was covered. And if you go down, you can see like it is slowly increasing. That means it was trying to optimize the location of those facility, and it has gone up to 25%. And if I click over here, so you can see like the minimum of 8, and if I do it, there is a maximum of 27% of area coverage we got, and this had no violations. That means this violation would have been 1. For example, there are certain results where the violation was 1. Okay, if I take this result, I can choose that column and I can choose run selected. So that means it just takes the facility values, and you can see some of the facilities was inside this red zone. That means it takes as a violation inside the algorithm, but we don't want that result. And you can see one of the highest coverage, which was 27%. If I run that, you can see the regions where all those facilities were kept, and you can see this was the maximum coverage obtained. If I run for more time, you get much better result. So this was just with the line of sight. It took maybe like 2 or 3 minutes for this run. So once you obtain a result, you can change it to radar, or you can even start from the radar itself. So I'll just show how to do with the radar. So I'll just come back here and I will choose a radar. and I will choose maybe just 4 radars. I'll choose a file radar, click on apply, and I go to grid. Grid file is constant. I do an apply. You go to optimization 5. I may stop this in between because it takes some time. um, you go to the execution tab and I click on result display, and the moment I start click on optimization, it will start running with respect to the area covered of for the radar. Please note that it is applicable for comms or any other object what you select. So I just click on optimization, and you can see now the optimization is running for a radar, not just the line of sight. So it is trying to optimize the area covered with respect to the probability of detection. So I had given only 5 generation and 10 populations. If you give more generations, more populations, you end up getting better results. So right now I have been reading radar objects. In the future we can add over here, or directly load a scenario and just choose your radars from that. It's not very difficult to set that up. And finally, once the result is over, you will get the same optimization result like this over here. It takes around 50 runs. So you can see like it is trying to place all those 4 facility all over the region. So once the run is over, you can again choose the area covered, maximum area covered, and do the computation.